Hello, welcome to today's class. Today we're going to be looking at neckness. Particularly, we're going to be treating tension in strings. So we solve those two problems, tension and strings. So we attack this problem using just an example. We have two rods suspended by means of a wire or a string. Their masses are, this is M1 and this is M2. For their weight, we know that weight is something as force is mass times acceleration with the gravity. So their weight will be, W1 will be M1G, while W2 will be M2G. Now, this is a string, so there's a tension. If the two masses are in equilibrium, in which case it doesn't move either way. What it means is that you can neglect the tension, because it will cancel out, the effect of the tension will cancel out as it affects the motion of the bodies. Now, we assume, if we assume that M2 is greater than M1, what it means is that this system of two bodies will move in the direction of M2. So how can we find question? Find one, the acceleration of the system, and two, the tension and the strength. If I want to space, I'll be very brief. Now, the tension is in the string. It always acts in the opposite direction. So to the mass attached to it. So tension has to be this way. Now, with respect, since the motion is in this direction, meaning because M2 is greater than M1, so it has to move, the system will move in this direction, the direction of M2. To solve question number, we'll have M2 is greater than the tension. That's the reason it moves in this direction. And that will give us, of course, we're dealing with weight. The weight will be M2G minus tension, so that dimensionally it will be the same. Because if we use M, the dimension of M, or the unit of M is kg, while the unit of tension is Newton. So once we multiply M by G, we have Newton to be dimensionally the same. We equate it to the equation of linear motion, which is M2 multiplied by acceleration of motion. That forms our equation 1. Now, because the direction is in this motion, it means tension, if T is greater than M1. So tension will be here with respect to M2 is greater, so minus M1G, so that tension and this term, which is weight, will be dimensionally the same, equals M1 multiplied by A. That forms our equation 2. So it's now a question of just simple equation. You can make T the subject formula using equation 1 and substituting 2, or you just eliminate, because T is plus here is minus here. We just add equations 1 and 2. So adding equations 1 and 2 means M2G minus M1G equals minus T plus T is 0 equals M2A plus M1A. That gives us A into M2 plus M1. Therefore, we'll have A into M2 into M2 plus M1 equals, we bring out G equals G into M2 minus M1. So therefore, A gives us, making A the solution, so the formula we have M2 minus M1 all over M2 plus, M2 plus M1 into G. This is the answer. This is the solution of M2. This is also the solution of M1. The tension in the string. That is question number 2. So I'll be wiping this sketch, so we don't have space. Now our questions are still, questions 1 and 2 sacrosanct, are still the same. Now we found A, so what we do is to either use question 1 or 2 to calculate the tension. Okay, let's take 2T minus M1 G equals M1A. And so it's making T the subject of the formula, means T is M1G plus M1A, which is M1 into G plus acceleration. This is acceleration due to gravity, while A is the acceleration with calculus. Of course, we do use our vectors to put that, but we can neglect that for, we believe, basic physics teaches that. Now, we substitute, our A is here. A is M2 minus M1 over M1 plus M2 into G. So when we substitute that, substituting M2 minus M1 over M1 plus M2 into G for A, in our equation we have plus M2 minus M1 all over M2 plus M1 G so just a question of algebra. I can wipe this. We have M1 is 1, I have M1 into G into M2 plus M1 plus M2 minus M1 into G all over M2 plus M1. So that gives us M1 into G M2 plus M1G plus M2G minus M1G all over M2 plus M1. So M2 cancels, M1G cancels M1G. So we have M1 into M2G plus M2G all over M2 plus M1. And that gives us 2 M1 M2 all over M2 plus M1 G. You can remove this. So we have T finally equals all over M1 plus. So this becomes the tension and the strength. The choice of equation is not important. If we use equation 1, we would still have got the same thing. I don't choose equation 2 to arrive at my answer. I hope this helps.